Hi guys, welcome back to Road Tutorial Chapter 5. So in this chapter, we're going to learn what is road module and the criterias and the rules for creating a module. We will then implement a full adder and an n-bit adder building upon the exercises completed previously using the road module. Okay, so um basically, last chapter we seen and we learned how to build an ambient adders, and this chapter we will convert everything to module. So if you have existing or prior experience with system Verilog, you may already be familiar with the concept of a module. So in road, module is similar to the system Verilog module, but in road, module has inputs, outputs that connect them. So there are like several rules that must be followed when you using road module. Alright, so let's look at the rules itself. So the first rule, all logic within a module must consume only inputs from the inputs or adds inputs methods to the module directly or indirectly. So in this case, we can just think of let's just focus on the add inputs methods for now. Okay, so we have a class, and then you need to have this one going to be your module name. So going to be class, your module name, extend module. So this is the key things. Extend, you need to be extend the module. After that, we have an example module. In this case, we have like a module name called example module. So here is going to take on a logic A, and we want to add this A to the module input. So we need to call add input function. And let's say if we want to assign the output, right? So how we're going to do that? We're going to use the add output function. Okay. So in this case, example module is a constructor that takes in a logic A, and then it will add the logic A to the module input, and then it also declare a module output. In this case, add output B, and then it's do all the assignment here. Okay. So what's the second rule? The second rule, any logic outside of a module must consume the signal only via outputs. Okay, so it need to be from either output or add output method of a module. So in this case, you can see from here. So say that we say the same, we have like example module. That's extend a module. So we directly know that this is road module, and then we need to add the add output input and output, and then your logic might use the logic from the A and B here, since we already override it. Okay, so if you want to use any of the output of the example module, you need to create a getter function. So we want to create a B that the output of the name B. It will match back to this add output. Okay, so the third rules, logic must be built or must be defined before the call to the super.build, which always must be called at the end of the build method if it is overridden. What does this mean? So when we have system Verilog, when we have road module, we can actually use this road module to generate the system Verilog. In fact, this is one of the ways or one of the common practice for a lot of our users that is using road right now. They write their system in system Verilog. They write their system in road. They write their design. They design their hardware in road. After that, they generate the system Verilog. Okay, so they actually want to utilize the flexibility of like writing hardware in high level language. So that's the reason why they use road to write their design. Okay, so let's do some simple module, right? So let's take an example of how to create a simple road module. So the example below show a simple module created with one input and one output. Notice that add output and also add input are used as mentioned previously to register input and output ports. Another thing to note is that the logic of the module here, output, then we use assignment operator to assign like input to the output is included inside the constructor, so that this dot build function instruction will pick up the logic during the execution process. So let's see what does it mean. So we have a simple module, that extend module, and then this simple module take on a logic type of input, but this input is just logic, it's just signal. So we need to register this signal, this input, to the port of the simple module, to the input port of the simple module. So that's why we use add input. Next is we want to create the output port. So how we just say like add output to the out. Okay. So now we can connect the input to the output port. Yeah. And then see from here, um we can just say like final input equal to constant one. After that, we give simple module value constant one. After that, we build it, and it should return the value of 1 since it's just a direct connection, right? The output here is going to be 1. Alright, so now we can just try to write our code and see if we can get the similar result. Yeah, feel free to pause the video if you are confused, and or you just comment out on the comment section if you are confused on anything here, because this is a very important chapter for you to continue in using road, right? Okay, so let's bring up. Okay, so this is the tutorials that we did on last time, so don't delete it. In this case, I will just create a new file, just say like simple module. The reason I don't delete it because later on we will be refactor this code to system verilog module and see how it's done. Okay, so simple module. So the first things we need to import road, definitely this one. Let's just import road, and then we after that we need to create a road module, right? So just create a simple class here. In this case called class simple module extends the module, right? Okay, so what is the module? If you still remember, the module is going to take on one input and just connect it to the output, right? So we can just create a simple module constructor here. Okay, so the simple module will take in one input, maybe logic A. Okay, logic A, and then we need to register this A, right? This A in this case is going to be the add input. Okay. So what's the name? We're going to name it A. And what is the signals that you want to register in this case? In this case, it's going to be A as well. And even if you, yeah, the reason that you can actually write it this way, but you kind of like reassign things, so I don't do it. Okay, so the next thing is you want to create another signals. Let's see, let's call it B signals, okay? So this is like var B is going to be equal to add outputs. So what's the output names? We're just going to say like B, and then we're just going to be a very straightforward assignment. So we're going to assign A, it's like, sorry, we're going to assign A to the output port, right? It's going to be something easy here. Sorry, it's going to be something easy here. And then how we actually want to access this output port, right? So we just, as we said just now, in order to access the output pin of the module, you need to create a getter. So in this case, we're going to create a getter of B. So logic get B. And then we're going to get the output of the name of the signal name B. Okay, so this is how we create a getter function. Okay, so now we can just create a main function. Let's just quickly create an instantiate final sim simple module, just limit sim module, this case, and then initialize simple module. Okay, so this is the A, right? What is A? A is a logic. So in this case, I'll just say like logic A, uh, yeah, to make simples, I would just say it's like, instead of like using the put signal, I will just assign it to a constant of one, like the example just now. I can still use put, but in this case I want to make a constant, so we can straight away see the result. Okay, so the next thing is we need, after we like instantiate the module, we need to build the module. So sim module, we need to build it, right? But notice that this build, when we hover it, okay, it says that it's actually written a futures. What is futures? So futures is something in the asynchronous programming. Is going to say that I'm going to build for you, but I'm not going to you I'm going to return the result later on. Yeah, so it's going to be a futures. Okay, so you can read about futures, read more about futures in the Dart programming website. Yeah, so what you're going to do is going to create an asynchronous, since this is a asynchronous function, build is an asynchronous function, and we want to await it. Okay, so now we can actually access, I'll just, instead of using the aspect like in the tutorials, I'm just going to print it. So sim module, and then .b dot value dot toInt. And if everything goes well, you will see that this going to show 1. Yeah, because why? Everything is just a simple module. It just assign A to B. So what we can do, we can actually see system write-up from the road as well. So how we're going to do it, we can just say sim module dot generate syntax is run, and then we can see this is the system write-up generated by road. Okay, so this is how you actually create a module in road. So in the next tutorial, in the part 2 of the tutorial, we will be looking on how we can actually convert our um how we can actually convert our mbit adder into road module. So we can generate system verilog code out from our mbit adder. Okay, so until then, happy coding.